12.5 is about expected value. It's about calculating, interpreting, and applying expected value. Expected value is a way of using probability to figure out the average of what you would make for each possible outcome. Okay, so what you're going to do when you're using the expected value formula is you're going to figure out your winnings or losings or the number of points or the amount of money it costs you for each outcome of your experiment. And that money amount is going to be like, this would be the money amount or the point amount, the value of the first outcome. That's what the little 1 means. And this would be the value or the money amount of the second outcome. And then we're going to multiply each of those values by their probability. So we're going to multiply value times probability, and then we'll add up all of our values. So each of our outcomes might have different probabilities. They might also have different values, and then we'll multiply those together and get our total by adding in the end. So in practice, what this means is I'm trying to find the average profit. The expected value doesn't tell me how much I'm going to make on any given day. It's just going to tell me an average. So because probability is unpredictable, you might get lucky one day. You might sell a whole bunch of chili or a whole bunch of lasagna, even though that's not your probabilities. So expected value doesn't tell you how much you're going to make in any given day. It does tell you the average that you're going to make over time. So each of the outcomes for this particular experiment are going to be stew, soup, and lasagna. And I like to keep things in a table, so this is already all kind of set up that way. And then we're also going to have the value for each of those items, and we're going to have the probability for each of those items, and then we're going to have a last column that is probability times the value, or value times probability. Doesn't matter what order you label those. And then in the end, after we figure out this whole column, we're going to add that column together. So if I can sell some stew, then I'm going to make 34 cents as the owner of this restaurant. I sell 12% stew, so the probability of getting someone to order my stew is going to be 0.12. And to get the probability, to get the part of this expected value, I'm going to do probability times value. And I'm going to do that for soup and lasagna and chili. I'm going to fill those numbers in. Remember, this column is the probability times the value for each of those items. I'm going to pause right here so that you can try this yourself, and then I'll show you how to get the answer. Please come back to the video after you have tried the problem. Okay, when I made that column of doing value times probability, I just did it on a computer so it'd be easier to read. I got all of these values. Now, it doesn't really matter that, I don't need to round. It's not that many decimals. I might as well just use all of my decimals. My last step to find expected value is I'm going to add all of these numbers together, and I can use a calculator for that. What I get when I did that, I did it on my computer, was I got 62.03. So the expected value for each meal that I sell is going to be 62.03 cents. It's not possible to make 62 cents because that's not any of our particular profits, but on average, we'd expect to make 62 cents for these meals. So if I'm going to make 200 meals to figure out the expected profit for making 200 meals, I'm going to be doing 200 times 0.62 so that I can figure out what that expected value would be, or that expected profit. And what I would expect to make would be, just grabbing my calculator, I would expect to make $164 and $124.06. I'm not expecting to make it, I wouldn't make exactly that, but that would be the expected outcome of running this restaurant. Okay. Example 2, we're going to play this game. It's a charity. We're going to figure out if we spin 3 times, we would like to get 3 even numbers. All of the numbers are even. If we win an item that's worth $4. So there are 2 outcomes for this experiment. The first outcome is that we win, and the second outcome is that we lose. If we win, we're going to get a $4 item, but we still have to pay $1 to play the game. If we lose, we just have to pay $1 to play the game. So the value for winning is $3 and the value for losing is -$1. Okay, the probability of spinning 3 times and getting 3 even numbers, well, the probability of getting 1 even number would be 1, 2, 3 out of 6, or 1/2. Oops. But I'm spinning 3 times, so it's going to be 1/2 times 1/2 times 1/2. And so it's going to be 1 out of 8 is going to be the probability of winning this game, which means that the probability of losing this game is 7 out of 8, which is just 1 minus 1/8. So then if I do the value times the probability, this time they're fractions. It's okay to multiply fractions together. This would just be 3 over 8 and -7 over 8. It's kind of nice that they have a common denominator because we're just going to add those together. We're going to have an 8 in the denominator, and then 3 minus 7 would be -4. So the total would be negative. And remember, this is money, so it makes sense to talk about this as a decimal. I would expect, if I play this game, on average, I would expect to lose 50 cents. That means that if I'm the one running the game, I'm okay with sometimes handing out $4 prizes because I know that in the long run, each person is going to lose 50 cents. So it's going to be worth it for me to run this game. All right. The next example is about how to figure out which insurance plan is the best option. A car owner is considering 3 options, and even though this looks like a table, we're going to do things a little differently in this one. There's one option where we have an annual premium of $480, and so for option A, there are 2 possible outcomes. One outcome is that we need a repair, and one outcome is that we don't. If we use option A, then we're going to have to, the value for needing a repair, well, we have a $0 deductible, which means that if we get in an accident, the insurance company is going to have to pay for all of our accident, but we're going to have to pay $480 if we need a repair. And we're also going to pay $480 if we don't need a repair, because that premium is going to get paid no matter what. So that means I don't care what the probability is. Well, I'll figure out what the probability is. The probability of needing a repair is 0.1, and the probability of not needing a repair is 0.9. And so we're going to do 480 times 0.1, which would be 48, and 480 times 0.9, which would be whatever 48 times 9 is. 36 plus 7 is 43, 432. Add those together, and guess what you get? You're going to get 480, which really shouldn't be a surprise to you because 480 is going to be the cost no matter what happens. So for option A, our expected value, whether we need a repair or not, is going to be $480. It's different if we're doing option B or C, and I'm going to do B with you, and then I'm going to leave C for you to try. If I do option B, the two possible outcomes are I need a repair or I don't. If I need a repair, the value is going to be $447 less the $200 that it's going to cost me for my deductible. The cost of it would be $500, but I only have to pay $200 because that's my deductible. If I don't need a repair, then I'm still going to have to pay the premium, $447, but I'm not going to pay any deductible because I didn't need a repair. So this plan, the probability for this event is going to be 0.1, and for this event is going to be 0.9. And then I'm going to do this multiplication, and I'm going to grab a calculator and do that. Pause the video. You can do the same. We're going to figure out, well, first of all, this number is 647. I'm going to do 647 times 0.1. Actually, know that one. That would be 64.7, and then we're going to do 447 times 0.9. Go ahead and try that, and then we'll figure out the expected value for plan. This one would be 402.3 when I multiply value times probability. And when I add these together, I get $467 because I forgot about the pennies. So $467 for this second option. That looks like the expected value. If I get into an accident, it looks like it's a better deal to use option B. I'm going to leave option C for you, but you're going to do the same two events. You need a repair or you don't, and you're going to have a deductible this time of you have to pay the $500. This is another insurance question, which I will leave to you. Remember that the options when you have an insurance claim question, I need a repair or I don't need a repair. Okay, so with the plan that has no deductible, the expected value for both, the cost for both needing a repair and not needing a repair are going to be $1,400. There's going to be a 0.5% chance that 0.05 because it's 5%. There's going to be a 0.05% chance that I need a repair. And there's going to be a 95% chance that I don't need a repair, but it doesn't really matter because they're both it's going to work out to be $1,400 in the end. Because the expected cost is going to be $1,400, I don't care because there's no deductible. But we have to do that same process for event B. In that case, if I need a repair, the cost is going to be this less this. If I don't need a repair, the cost would be just $1,250. Right. This is how you conduct expected value. The purpose of expected value is to tell you on average what you would make with each of your outcomes with your experiment. So in this case, if the experiment is for Latoya, how much is it going to cost for her on average if she goes with the first homeowner policy versus the second homeowner policy? All right, good luck today.